So if you look at the requirements of the basic cryptography, what we have explained in the previous videos, so in this cryptography you will be required with a plain text, that is the input, a ciphertext, that is the output, a secret key, then the encryption algorithm that is done at the sending part, and the decryption algorithm that is done at the receiving part here. So these 5 ingredients are required for a cryptography: the plain text that is at the sending part, the ciphertext that is at the sending part as well as at the receiving part, the secret key at both the sides, the encryption algorithm at the sending side, the decryption algorithm at the receiving sides here. So let us see what are the types of cryptography. So there is no rigid classifications in the types of cryptography. It is broadly divided based on their functions here. Based on their functions, the first type is the types of transformation. What type of transformations you are doing, what type of transformation techniques you are using. Based on that, it is divided into 2 types: substitution cipher and transposition cipher here. So we'll see what is a substitution cipher, and also we'll see what is a transposition cipher here. So based on the transformation, it is divided into substitution, and one is the transpositions here. Next, again, based on the types of key or the nature of the key, that is that secret key that is used at the sending part and at the receiving part, it is divided into symmetric cipher and then asymmetric cipher here. One is symmetric cipher and one is the asymmetric cipher. In symmetric cipher, the secret key used at both the sides, that is the key used at the sending side and the key used at the receiving side, are equal. Okay, means the same key is used at both the sides here. Whereas for asymmetric, I have written here the key, if K1 is used at the receiving part and K2 is used at the if K1 is used at the sending part and K2 is used at the receiving part, then K1 is not equal to K2 here. It means they are different keys here. So such type of asymmetric cipher, we call them as public key cryptography. If you are using 2 keys and if the 2 keys are not similar or equal at any cases, then we call such kind of encryption as asymmetric cipher, or the other name is public key cryptography. So one example is the RSA algorithm. So this RSA algorithm is an example of public key cryptography, and public key cryptography is just another name for this asymmetric cipher here. Next, based on the nature of input, it is also divided into stream cipher and then block cipher here. Stream cipher, if you are using continuous, and if the input is continuous, that is, you are supplying the input in terms of binary numbers, and if the inputs are continuous, then we call it a stream cipher. And instead of this continuous cipher, if you are making a rigid or a compact or a block by block, then we call it as a block cipher here. For example, if the stream cipher looks like 0, 1, 2, 0, 1, 0, 1, 0, 1, 1, 0, 1, 1, 1, and so on. If you are continuously providing such kind of input to the stream cipher, if you are providing continuous binary numbers, since everything will be converted into binary numbers here, and if you are providing this one as the continuous input, then we call it a stream cipher here. So in case of block cipher, instead of providing this continuous binary numbers, you can just make a block here. Block, how many bits make a one block, it is left to you, or left to that particular algorithm. So maybe 1, 2, 3, 4, 5, this make the first block, then 1, 2, 3, 4, 5, this makes the second block, and so on. Okay, and so on. If you are inputting in such a cases, this is the first block, second block, and third block, then we call this one as it's a block here, and the number of bits in each block are equal. Okay, if it is of 5 bits, then it is of 5 bits, and so on. And if it is of 64 bits, then this will be of 64 bits, this will be of 64 bits here. Okay, so in case if you don't have 64-bit at the last block, then you can append some binary numbers here. Okay, we can append it. So there are called a there are called a bit stuffing here. Okay, so in that case, if you are inputting the cipher, if the input are in the form of a block, then we call it a block cipher here. For example, your DES and AES are the block cipher algorithms. So here in DES algorithm, the number of bits here in one block is of 64 bits. And the number of bits in AES is of 128 bits here. So based on the nature of the input you are supplying, if you are supplying the continuous binary number, then it is a stream cipher. Or in case if you are not providing the continuous binary number, or in case you are supplying in case of a block wise, then it's called a block cipher here. The common examples are this DS algorithms and the AS algorithm. So both of the algorithms will be studied later on. So what you know in this class is that you must make sure that what are the requirements of the basic cryptography. You must know what are this, where is the plain text used, where is the ciphertext used, what is the secret key, where they actually are used, what is the encryption algorithm, what is the decryption algorithm. Okay, these are the encryption algorithm and decryption algorithms are nothing but the transformations algorithms here, or the transformation procedures here. If it is used to get the ciphertext from the plain text, then it is the encryption algorithm. And if you are getting the ciphertext or the plain text from the ciphertext, then it is the decryption algorithms here. So based on the secret key, whether the secret key used at the sending side or the secret key used at the receiving side are equal or not. If they are equal, then we call it a symmetric cipher. If they are not equal, then we call it as the asymmetric cipher here. Okay, so then types of cryptography, it is not, I also mentioned that it is not very rigid transformation. We have already divided based on the functions or the nature of the key or the nature of the input here. Based on the transformation, it is a substitution cipher. Substitution means in the alphanumerical character, A is substituted by any number as B, or maybe B may be substituted by P. Okay, there will be certain rules of substituting it. Either A is substituted by A itself, or A may be substituted by any letter in the English alphabet here. That is what we call as a substitution cipher here. So there will be a particular rule how are you substituting A with any other letter, or there should be a particular rule of substitutions here. There will be a particular rule of substitution. You cannot substitute by any random letters in the English alphabet. You can substitute it with any letters in English alphabet following a certain rules. The particular rules will be studied when we study about this substitution cipher here. So substitution means, by the name itself, it is substituting a letter with any other letter in the English alphabet. Maybe the letter itself, or maybe any other letters in the English alphabet, but it should follow a certain rule of substitutions. Next is a transposition cipher. In transpositions here, we are not substituting the letter with any letter of the alphabet, but the letter in that particular words here. Okay, means transposition means we are changing the positions here. Maybe A comes last, E comes second, this P comes here, then again this P comes here, and L may remain the same here. For example, it becomes and L may come here. Okay, maybe it is just the permutations here, just the permutations of the positions here. Okay, here it may be like L, P, P, A, E here, maybe. Okay, but we are not substituting A with Z or A with any other in the English alphabet, but we are substituting A with the letter in the word itself here. The word itself means we are changing the position there. A happens to be the first position. Now in the ciphertext it becomes the fourth positions here. Okay, so we can substitute in this manner here. Then we call it as the transposition cipher here. We are simply changing the positions of the letters in the word here. Then we call it as a transposition cipher. So based on the nature of the key, what I have told you here is a symmetric cipher. Suppose this is the sending part and this is the receiving part here. Then we are sending a particular message through encryption. Then I use a particular key. In that key, this key is used for encryption here. And again, if this similar key is used for decryption again, then we call this kind of, this becomes K1. Here also K1 is used. Then we call it as a symmetric cipher here. Or in case if K1, you use K1 for encryption and use another key for K2 for decryption, then we call it the asymmetric cipher here. So this is the case of the classifications of the cryptography techniques here. Okay.